so we've seen a lot of really wonderful things. I think what I'm going to just end with, as I mentioned, is just a roundout of the current state of affairs, as well as kind of what's coming in the future. So our big focus for Q2 of this year was largely on LLMs, both different architectural types as well, right? So talking about decoder-only transformers, encoder-only transformers, as well as encoder-decoder transformers. So the architectures that we focused on in this particular quarter, just to kind of give you an idea of what's available in Model Zoo and as part of our overall functionality, right? We're looking at things like GPT-J, as well as our own open sourced GPT. We're looking at models that are of the GPT variation, and this includes things like GPT-J, which is our own open source version. We're looking at a variety, we've provided a variety of different attention types, including the sort of the regular multi-head attention, as well as multi-query attention as part of Llama 7B, and then group query attention that's available from Llama 2, the 70B variation. On top of that, there's other building blocks that are available in Model Zoo as well, right? Today we have things like ReLU, the GALU, the GELU activation function, SWIGLU, there's from Llama, as well as a variety of different positional encodings, fixed, ROPE, as well as learned from GPU. The models that kind of utilize this variety of different architectures are ones that we're familiar with, right? So we have Llama, all the variants in various different configuration. Now, for all of these as well, you'll find both the config YAML files as well as the reference implementations inside Model Zoo, Mistral, GPT-2, as I mentioned, 3J, MPT from Mosaic, Falcon, Bloom, Jace, as we've seen, as well as a few coding ones, and then BTLM, as Natalia mentioned earlier. So these are available as part of the decoder-only transformers. And then, in the encoder space as well, we have a variety of different BERT-based models that was sort of the focus as part of Q2. And then a bunch of different encoder-decoder versions as well with T5 and just the vanilla transformers that are available. Kind of looking a little bit outside of the transformers space here in the decoder models, we also, one of the big focuses for us in this quarter was to look into multimodal, right? And so with 2.2.1 and with some of the new releases here, you're going to see support for Lava and other sort of multimodal varieties going forward. You'll also be able to do other modalities and encoder-decoder models as well within the multimodal realm. There's also support for a number of different embeddings and techniques as part of the model workflow, right? So we're looking at RAG, retrieval augmented generation support with things like DPR, the dense passage retriever that's available as a model reference implementation, as well as config YAMLs in Model Zoo. And then also, as we heard a little bit yesterday, support for alignment techniques with DPO, which is gaining traction recently in sort of aligning LLMs to behave more in a way that's suitable with human preferences. So these are also now available as part of Model Zoo. This was really the focus, to have robust support for these popular models as part of our Model Zoo. Looking at, kind of the state of affairs and maybe looking a little bit ahead as well, right? In the first half of 2024, we're looking to extend our support for LLMs in general, looking to bring on larger variants and continue to keep abreast of new research that's coming out, new foundation models that are being trained in this respect. We're looking to add support for mixture of expert models as well, right? Increasing the support there, for example, with Mistral 8x7B and 8x22B, and then expanding on our footprint in multimodal support. So today, we, of course, have support for visual question answering, as you saw a little bit yesterday in the demonstration of the Lava model. And today, again, we have support for text and images and limited support for code and high quality charts and graphs and things of that nature, with the output being focused on text generation. Now, all of this is available in Model Zoo for training, for pre-training, as well as fine-tuning, right, for domain-specific adaptation, for financial data, for healthcare data, for different modalities or different domains that might be relevant. And this is where there's a lot of active research that can be done. And in a second, I'll show you an example of what such domain adaptation can give us in terms of fine-tuning these models for chat-based, as well as for a specific healthcare example that we can take a look at. Looking ahead in the second half of 2024, again, looking to expand our footprint in multimodality and mixture of experts, with accepting different modalities as inputs, right? Different types of data formats, including other types of sequential data, might be DNA sequences, might be protein sequences, different domains in biology and chemistry, as well as things like other modalities with video encoders, potentially audio, as well as different modalities that sort of pop up and become relevant. The priorities will shift again based on the most relevant modalities and where the most active research can be accelerated. In terms of output, right? So the inputs might be video and some of the sequential data. The output as well, we're looking to expand support and be able to generate images, and then expanding our mixture of expert models to become multimodal as well as the industry kind of flows in that direction. And then looking ahead in 2025, the large goal is to really fill out the scope, right, of modality, so that now it's not just images and text that these models can take in, with text generation being the primary mode of output. We're now talking about all to all, right? Whether it's image, video, audio, sensor data, as new modalities become available, being robust to supporting those modalities as inputs, as well as generation in those modalities as well. This is the goal for 2025. Now, this is being able to bring in a pre-trained encoder, a pre-trained model for any of these modalities, and training a cross-projection layer to make it compatible with a LLM backbone, but also being able to pre-train these models directly on Cerebras hardware from scratch. So using your own custom data sets to make these models adapted to a particular domain is going to be sort of a focus for this, as well as exploring in 2025 new architectures, right? State-space models are coming into the forefront, and then looking, of course, into other techniques that can be highly leveraged as part of our hardware and provide superior performance. And one of the things there is going to be looking into, for example, providing convolutions and sort of merging that in with GPT architectures. There are other research areas, there are other architectural modes that we do want to continue looking into and supporting. And as with any product roadmap, as we learn more and as we chat with folks like you, this is an excellent opportunity for us to collaborate and figure out what our roadmap should look like as we look ahead to 2025. Now, a couple things I want to showcase as part of what we're doing today is this notion I mentioned earlier of domain adaptation. So one thing I do want to talk about is in partnership with one of our organizations that we work very closely with G42, we were able to build a model called M42, which ends up becoming, it became one of the most sort of performant and highly accurate models in clinical settings. And in fact, it can does very interesting things in terms of its performance on the US MLE medical licensing exam. So to give you a little bit of context here, this is some of the work that we encourage you to explore and look into. This is one of the things that you can do with our existing models, is to fine tune it. And so what we did here is we took Llama 7DB, an existing reference implementation, and we trained it, we fine tuned it with specifically curated healthcare data that, in conjunction with the Core 42 team at G42, we sort of worked together to curate this data set specifically for training Llama 7DB. And we trained this on our Condor Galaxy cluster as well, and used our CS2s. Obviously, this is sort of a boost here because we can fit these very large models into the system and train in a performant way. All of the conversations we've had over the past couple of days gives you an idea for how that's possible, how you could do this very easily yourself. And the results, as I mentioned, were phenomenal. The M42 is really trained to be very specific in answering questions in the medical domain. So it's very specific data, very specific functionality here. And it does end up passing USMLE with a 72% accuracy, which in doing so, it outperforms GPT 3.5 on the same sort of benchmark there. And we've made this available to the entire healthcare community, of course, and in partnership with Hugging Face, released it as well via the G42 cloud. So let's take a look at the example itself. What you're going to see here in this demo is an interaction with the sort of a chat-based interface for the M42 model. The question that we're going to be seeing here is going to be a very specific question. We'll go over what the question is, and the answer essentially is coming from a 2024 research report. This is the type of data that's being trained to enhance M42's Med42's model. This is kind of what it was fine-tuned on, and the responses you're going to see are again going to be very, very specific for the medical domain. So let's take a look here. All right, so the user is going to type in, are adipose tissue distribution scores correlated with patient frailty or surgical outcomes? Now, I'm not going to try to interpret this question. That's way above my pay grade, but you can see that's very domain specific, and it's very related to the healthcare domain. And typical models out of the box, even ones that are pre-trained and then specifically fine-tuned for chat format, will not be able to have a robust performance on this type of very specific domain because they just haven't seen that amount of data, that type of data, that curated data set in their pre-training sort of steps. So now that we have pre-trained this, it's able to come back with an answer, according to this specific document, which is a 2024 research report published at such and such. Oops, let's go back here. Published at such and such date. Body size and adipose tissue distribution scores were in fact not correlated with patient frailty. And so this is kind of the response that it's coming up with. And now let's take a look at the level of accuracy of this response when we go to the next page. And again, to reiterate, right, this is what the document looks like, where it's coming up with the response. This is the type of data, the curated data set that we've used to train and fine-tune Llama 7DB, and in fact, then create the Med42 model that you're looking at. And sort of embedded in here in the conclusion section of this report is the answer to this question, whether these two things are correlated, and in fact, they're not, based on sort of this very specific part of this specific document in the research report. And just to drive the point home, you can kind of look at the differences between an untrained or rather unfine-tuned general model and a model that's been now, has this pre-training, but then is fine-tuned specifically for healthcare domain. The responses here with Med42, of course, it comes back, as you saw earlier, with the right response that these two things are not correlated. But when you ask the same thing to GPT-4, which has data that's maybe a little bit outdated now, 2023, and of course is also not fine-tuned on medical specific domain data, the answers there are going to be, it's going to come back with maybe an incorrect response. Here you can see it says that tissue distribution scores do correlate with patient frailty, when in fact the answer is that, if you look at the previous slide, that in fact does not correlate, right? So very nuanced, very specific response for this very technical question in the healthcare domain. And the key difference here, where we're able to get a right response, is by fine-tuning it. And this is the kind of research that's enabled today, as part of the Cerebras platform and the models that are available, the reference implementations that are available in Model Zoo. So just to summarize a little bit of what we've discussed here, right? Today, we have industry-leading performance on state-of-the-art LLMs, as you've seen with Llama 3, Mistral, GPT-3, and so on and so forth, and support for visual question answering with multimodal models, right? And the input modalities here are going to be text and images and things like charts, graphs, and code. These are all available out of the box for researchers to fine tune to custom domains and experiment, as we saw with Med42, how much performance you can get on specialized domains. And this is something that a lot of folks are doing, working with the models who reference implementations and making them domain specific. Now, this is the focus of Q2 for us in July 2024, and sort of looking forward the rest of this year. We're looking at mixture of experts models and enhanced support for multimodalities. In mixture of experts LLMs, right, support for Mistral 8x7b and 8x22b, and then multimodal, the ability to pre-train these modal encoders, right, for image, potentially even for video, as well as with high fidelity and high performance across a variety of different modalities in image and text. By the end of the year, expanding out the support, as we mentioned, for mixture of experts and for multimodality across any to any modal transfer, going from input modalities, text, images, video, and as we also mentioned, sensor data, and then being able to generate images as well, and going to other modalities for generation, with, of course, pre-training being possible for these encoders, these models that are modality specific, being able to pre-train those natively as well on Cerebras hardware. Before I move on and to closing remarks here, we would love to hear from you, right, on what you think about our roadmap in terms of the models and the types of support that we're expanding out. I'll go back to our slide here on what the future state looks like for the end of this year as well as next year. And I want to quickly open it up to see if there's any thoughts on the roadmap, and if there's other things that you'd like to see here. We'd like to understand why and how you'd like to push the boundaries. And I want to see if I can actually access the chat here.
Avi, I can also relay anything that comes in the chat.
Yes, thank you. Is there any questions or is there any comments on the roadmap that we can address at this point?
There is one question about multimodality.
Okay.
Question is, it refers to text, images, and voice, but what other modalities might that include?
I see. Yeah. So today, out of the box, as we mentioned, we can take inputs that are text and images. Going forward, we're going to be having support for a variety of different data sets, right? So in multimodality or multimodal models, data sets can take different formats. There can be image caption data sets. There can be images interleaved in between other text. So think about a document that has text, image, so interleaved data is important. And as you mentioned, audio and voice can become another modality where these are, maybe there's an audio file with a transcript, and we want to train, a contrast of loss image audio and text encoder for that purpose. There's a variety of different mixtures and combinations that you can use with all of these modalities. But I guess if it would help me to understand the specific nature of your question, is it that you're looking to do more with voice or audio? Maybe I'll direct that to the person that asked the question.
I wasn't really looking for anything specific, so just sort of just putting some feelers out there and see what people are doing.
Yeah. I mean, there's a lot of really interesting modalities that people are going towards, and then of course there's also there's some really interesting models coming out from Apple on UI foundation models, where these are models that are trained to understand very small images that have text and images embedded, interleaved data, but it's all sort of iPhone screens or Android screens, right? So there's a lot of really interesting multimodal research that's going in this direction, and I think we feel fairly confident that the industry is moving towards becoming more and more multimodal training with higher resolution images, higher resolution videos, audio, and so having any-to-any support as well with models like AnyMall. That's another model from Meta, I believe, that has multimodal support. And so bringing up models like this, I think will open up the gambit of what folks can experiment with Cerebras. So we're excited to work with you to figure out as well what other things you're seeing in the wild and what other things you'd like us to support. So we can keep an open channel of communication and set up regular sessions where we get feedback from you on what are some other models that you'd like to see in our model zoo, and how you'd like to expand and experiment. Great. Any other questions? All right.